Hi guys, welcome to another video, and today we're going to be looking at nuclear reactions. Now during alpha and beta decay, there are actual changes to the nucleus of that radioactive atom. But let's just remind ourselves about atoms first of all. You should remember that all atoms are neutrally charged. And the reason that atoms are neutrally charged is that the number of protons and electrons are the same. Now for any element, we have the symbol, and here I've just represented the symbol using X. We have a number at the top which we refer to as the mass number, and the mass number is the number of protons and neutrons. This number at the bottom we call the atomic number, and the atomic number tells us how many protons the element has. And remember that the number of protons and electrons are exactly the same for any atom. But we also came across in chemistry something like this, where we have atoms of the same element, for example, atoms of hydrogen. They all have the same number of protons, but they have a different number of neutrons. We would call these atoms isotopes. And that's just a quick recap before we get into this lesson. So let's take a look first of all at alpha decay. You remember from previous videos that alpha radiation is made of 2 protons and 2 neutrons. That means that alpha particles have a +2 charge because of those 2 protons. The alpha particle, which we represent using the alpha symbol, would have a mass number of 4 because it's protons and neutrons, and it would have an atomic number of 2. For some examples, they may use the helium nucleus to represent alpha decay. Both are acceptable as answers. So let's have an example of what alpha decay looks like. Well, let's say I've got an atom of gold. The chemical symbol is Au. There's 79 protons and 197 mass units. But let's say that my gold element undergoes alpha decay. That means from the nucleus of this gold atom, I'm losing 2 protons and 2 neutrons. So on the other side of the reaction, I will draw my alpha particle. This particle has been lost from the nucleus of this gold atom. But when we do nuclear equations, we have to make sure that the mass is balanced. So if I do 197 take away 4, that leaves me with 193. And if I do 79 take away 2, that gives me an atomic number of 77. I would use my periodic table to find the element using the atomic number, and that would complete my alpha decay. Let me give you guys one more example. Let's say we have bromine. The chemical symbol is Br, the mass number is 80, the atomic number is 35. And bromine also undergoes alpha decay, which means the mass number is going to drop by 4 and the proton number will decrease by 2. Using the periodic table, I can find the chemical symbol for the isotope. But I've also got my alpha particle that was emitted from the nucleus. And you'll see that the mass numbers on this side add up to the mass number on this side. So do the atomic numbers add up. So in general, we can say that during alpha decay, that mass number decreases by 4 and atomic number decreases by 2. Please check the website for more examples and questions for you to have a go at. So let's have a look at beta decay. Beta decay occurs when a nucleus has too many neutrons, and some of those neutrons turn into a proton. Well, when that neutron turns into a proton, it also turns into an electron, which is kicked out of the nucleus. So beta radiation, or a beta particle, is basically just a fast-moving electron, an electron that's been emitted from the nucleus. So let me give you guys some examples of beta decay using the equation. Well, the first example is potassium. And let's say I have an atom of potassium, and my potassium is going to decay by beta radiation. Beta radiation is just a fast-moving electron. Now, the mass of an electron is so small that we just ignore it. So we give it a mass number of 0. The charge on an electron is -1, which becomes its atomic number. Now, again, we have to make sure that the mass numbers balance on both sides. That means that we have the mass still at 40 mass units, but this time the proton number or the atomic number has increased, and that's because a neutron turned into a proton. If I use my periodic table, you should find that this element is calcium. The second example to go through would be carbon. And let's say that my carbon element went under beta decay. Again, from the nucleus, one of the neutrons will turn into a proton, emitting a beta particle. Now, there's two ways of representing that beta particle, and you have to be comfortable with using both of them. Remember, the mass doesn't change, so the mass of my leftover element must still be 12, but the proton number has increased by 1. Again, using the periodic table, you would see that this is an isotope of nitrogen. Because gamma decay, gamma is just a high energy wave, it's a part of the electromagnetic spectrum. There is no change in terms of mass or proton numbers when gamma is decayed, when a particle decays using gamma. Okay guys, thanks for tuning in. Stay in touch for another video.